Hey everybody, this is Larry. This is me going with Q3 of the weekly contest 48. Count the number of substrings with dominant ones. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about this one. Honestly, I should have been able to solve this one. I did end up solving this way later. Yeah, I did end up solving this way later, but I just honestly, the reason why I wasn't able to solve this was because I was trying to optimize too much. I did a premature optimization that I was trying to find a closed form for something that might or might not have a closed form, but I was just wrong on it anyway. So that's basically the idea. And I did end up taking a long time to finishing this one because the implementation is just so awkward and weird because I just felt like I was doing weird off by ones. But the idea here is there are a couple of key ideas. This is actually, just to be clear, a very difficult Q3. I mean, I didn't solve it, so I have to say it that way. But at least in terms of implementation, and maybe also we just haven't had a hard Q3 in a while. But in either case, for me, I feel like this is definitely one that is trickier than, maybe one of the trickier Q3s we've seen, right? There are a couple of ideas with this, with noting that you have this thing about number of ones, which is greater than number of zeros on a string. So, so that means that in a way, and I have this on my notebook, which I'm not going to show you because I don't know, you can't really see it. I'm too lazy to kind of set it up. But the idea here is that, okay, well, if you have 1 0 in a substring, then that means that you need to have 2 or at least 1 1, which is length 2, right? And if you have 2 zeros, then you have to have at least 4 ones, which is 6, right? And of course, you can kind of generalize this a little bit. Let's say you have 100 zeros, then now you can have up to 10,000 ones, which is 100 square ones, which is, right? But as you can see, roughly speaking, right, the max is going to be 40,000, right? So, I mean, I didn't do the exact math, but I just wrote, okay, so when it was 200, then you have right? So it's something close to it. It's going to be roughly this, right? So that means that if you have, I mean, oh, whoops, I think there's like 198 or something, right? But whatever, let's just say it's 200 for easier saying. But then the idea here is that you can never have more than 200 zeros in a substring because then you'll never like have enough ones to make it true, right? So this kind of gives forth an n square root of n idea, right? Of, okay, in that case then, let's say we have for every character in the string, then we can just check, okay, what if there's 1 0, what if there's 2 zeros, what if there's 3 zeros, ... all the way up to the square root of n, and then kind of do it that way, right? So that's basically really the idea. It took me a long time because I was trying to do, okay, so let's say we have the n square root of n based off the 200 zeros. I spent too long trying to do something that was like close form 200 to 200. Like, it's technically not 200 times 200 because I guess there are more, you can have more than 200 zeros. You can have n number of zeros really. So it's still n square root of n, but win another way, and I try to optimize it a little bit better. But that's basically, and then I just couldn't get the closed form on it. So what ended up working, and this code is very yucky, but I'm going to optimize this. We'll optimize it together. You could kind of watch this on the fastest speed, but we'll go over the ideas, right? So here, so now we just keep track of all the indexes of x, right? I just wrote this to kind of add an extra thing to kind of keep track of, because basically, I'll go over the code and it'll make more sense. But here we have just total, that's the total, and we bisect the next 0, right? And then here we go, okay, what is the, this is the number of zeros to consider, where this is the, this is the location of the next 0 of the index, and j is the number of zeros to take. right? So here, and maybe we'll rewrite this in a different order. This is the right side, which is basically it's saying what is the next 0 minus 1, right? Yeah, like basically this is the last index before the 0, and that is the right boundary. This is the number of zeros, which is j, because I mean that, I don't know, I just thought this was easier to read. And then L is just the length, right? And here this is the right boundary, I is the left boundary, so then you add 1 is the length, and then the number of ones is just equal to this. I have this thing called max freedom, which is a little bit wonky, but we'll talk about that in a second. I actually don't know if I need this max 1. I don't think we need this anymore, mate. Actually, let me run it real quick. Oops. Alright, we'll just give some it real quick. This should time out. So this times out, but we'll play around with some optimization. We'll just see if this still times out versus giving us a wrong answer. Should be a little bit faster. Oh, someone also said that maybe I can use if statements instead of min and max. But yeah, the idea. So I think hopefully this part makes sense, and then we'll go over this in a. Oh, is this the input? That is the input. Huh, that is just very wrong. Can I just say? There are no negatives, right? Why would that be wrong? That is so wild. Maybe I don't understand this part. Okay, but let's break it down a little bit, right? So this one, actually the solution is right, but it's just a little bit awkward. So basically this part is just the number of the smallest string, right? So maybe we can rewrite this as min string length is equal to plus right? And here if this is 0, then it could be 0, so that's why I have a max is equal to 1, right? But let's actually even write it out, just because, you know, less than or equal to 0, or less than 1, right? Then we can just write this, because, you know, a string has to have at least length 1, right? And then we can kind of remove this. But yeah, and of course, so the idea here is that like basically I'm looking at this part of the formula, right? And the idea here is that, okay, let's just say we have, you know, some strings. It doesn't really matter, but let's just say even all ones, just to make it simpler. If the min length that we have to do is 5, right? Say we have, you know, 1, 2, 3, 4, 5. This is the min length. Then the count is just, you know, how many places the left could be, the right to be. And if we kind of just like count it out, you know, because basically here, another way to say it is that, let's say the string is length n, and here we're trying to find strings of length, the count of the number of strings of x. Let's just say something like this, right? Oh, sorry, maybe yeah, right? That means that let's say we have some min length, right? Then now, and it's equal to say 5, right? Then now there's going to be one of length 5, one of length 6, one of length 7, one of length 8, ... right? And so, but if you subtract it out, that means that there's no 0, 1, 2, 3, 4, 4, right? Which is exactly the min length. That's basically how you kind of get this math, right? That's basically the idea. And then max freedom is basically how far this gets extended to the right, right? And the idea here between max freedom is, yeah, the idea about max freedom is that, let's say you have a 0 and you have some 1s, right? The idea here is just that, well, and you have another 0 here. So then here, our current right pointer would point to this 1, right? This is our right, as in the right, and this is our I, right, say. Well, in this case, we can only go to the left up to here. So that means that no matter what, we cannot extend to the left past this 0. So that's basically what this max freedom is. It's just counting the number of 1s that are past the last 0, and you can, you can kind of work out this math why this is the case. But that is basically it. And I start with some infinity value, which, okay, let's factor that out real quick. Right? And that's basically the idea, is that, okay, well, yeah, so so count is equal to this thing, right? If count is less than 0, then count is equal to 0, just because, we cannot have a negative number of things. And then if count is greater than max freedom, then count is equal to max freedom. Again, this is just so that we don't overcount things. Yeah. And that's basically the idea behind this one, real quick. Okay, well. Why is this weird? What did I write? Max freedom, this sets it. And then if this is greater than it, then, oh, whoops. How did that happen? Yeah. So let's give it a quick submit. I don't know if this is timeout, because we made it a little bit faster, but apparently yeah, okay, maybe it's still too slow. I mean, the thing is that during the up south, I did convert this to Java, and it's okay. Apparently this is okay too, right? So yeah. So that's pretty much the idea. And here you could actually get rid of the bisect left, noting that it's almost like a sliding window, right? So you can have next is equal to 0. You can start with next is equal to 0, while z sub next is less than I, then we can increment by 1, right? So something like that. Yeah, and that should be good as well. So you could get rid of the binary search really quickly. I just wrote that after the contest because I was like, it shouldn't matter, but yeah. And that's pretty much it. That's pretty much the idea. And 200 actually could be optimized as well. I chose 200 because it is I chose 200 because like the number that we said, right? It is 200 square, but you can actually even terminate slightly earlier. Maybe it's just, and this is a little bit lazy, but yeah, you can wait something like if I plus j times j, or j plus j times j, because that's the number of zeros. If that is greater than or equal to n, is that good enough to break? I think it's something slightly smaller than that, or bigger than that actually, but I mean, you could definitely do something like this for sure. And it'll be, ooh, how did that happen? Oh, I guess it could be exactly, whoops. Yeah, so that would work too. And maybe, yeah, and let's give a quick spin, right? So that would, I mean, you could also do like a square root of j thing, but yeah, but so that you, it doesn't do all 200 even for smaller numbers. It should be faster. After it gets accepted, we'll take a look at the submission times, and you can see that it is loading. But yeah, wow, that is actually really slow, an accept of 20 seconds. But you can see that, what did I do again? Oh yeah, with the early termination, I cut it down 7 seconds. And yeah, even the while loop version is slower than the binary search version though. I guess binary search is pretty fast, and this while statement kind of checks stuff. Right, let's try it again just in case that I'm like delusional. Now, I guess you can also just do like if c sub next is greater than I or less than I, then we just increment. That should always work. Yeah, because you don't need a while statement is my point, right? So we'll give it one more go, and I think that'll be my last optimization thing. But yeah, as you can see, you don't need Java, but it's still a little bit awkward. But yeah, for me anyway, it was definitely a very difficult problem, very much a struggle. So I don't know what to say, right? It is what it is. But yeah, which one did I submit? So, okay, this one is the if statement one, and this one is the binary search one. So I guess the binary search doesn't really change that much, or even the if statement really, but they're still both correct. Yeah. Let me show you the code real quick. So this is to get all the zeros. This is to get all these things. Yeah, kind of wonky to be honest. But yeah, what's the complexity here, right? I mean, I kind of did this math in a weird way, so forgive me. But yeah, but this is going to be obviously j is smaller than square root of n, or well, maybe square root of n, but yeah. So this is square root of n. This is n, and so this entire algorithm is going to be n times square root of n, and that's pretty much it. I should have gotten this earlier, but I just struggled with a lot of what I wanted. I tried to be too clever for this one, I think, and I was playing around with too many concepts. Eventually, I got it because I had to refresh everything in my mind, to be honest, and like got rid of a lot of like weird things that I was confused about. So yeah, and you can watch that next, right? So okay, let me make this slightly smaller so you can see everything. Okay, yeah, that's all I have for this one. Let me know what you think, and yeah, let me know in the comments what you think. And you can watch me solve it live during the contest. That's not true, but you can see me attempt it during the contest, and then I spend afterwards trying to get this. I don't know, I'm just not good at this. So yeah, thanks. That's right, but also there's only like 3,000, so okay, well, at least I got it right. Oh, a lot of people getting wrong on this one. What about this one? Also, no one got it yet. Let's take a look. So at least I have some time to catch up, though I'm a little bit slow. Substrings of dominant ones. Dominant once. No. Square of the number of zeros in the string. This is such a terrible format. 3. And it's 10. It's big enough. Okay. No one's gotten it yet though. This is 01, 11, so it's greater than or equal to. Okay. That's what this is. 5, 16. Okay. I mean, in theory, we want. Still no one's gotten it, or at least it could be just not updated though. It's not sliding window, is it? Okay, let's say this is the last one, right? I mean, n square is easy. Can we do better than n square? Why is this? Oh, I see. These are the non-dominating ones. What does it mean? What does it mean? How can we think about this in a different way? 0, 0. So this has to have length 6. So 2 is 6, let's say, right? So length 1 is going to be length 2. 0 is just, well, I mean 0 doesn't mean anything about 0 zeros. And it would be n square, okay. 2 is going to be 6, 3 is going to be 12, 4 is 20. What is there a pattern here? Pattern isn't even enough. We need more than that, right? Do you? But then it's the square root, right? So I guess maybe you could brute force it in a really clever way, but no one's gotten it yet. Someone's gotten this one, so maybe we should do this one first. I don't know. Alright, let's skip ahead just because I own this is a silly thing. Okay, YOLO. Okay, I'm not done yet, Larry. I forgot. One of those wrong answers is silly, and the other one I actually got a good use out of. Okay, but how am I 3 to 51? Did that many people get Q? Whatever. Am I just not fast enough on Q2? I guess I'm just. Maybe there's a faster Q2. Maybe I didn't realize. I did it maybe a hardcore way. Okay. Okay, so 42 people got it. More people got Q4, I think. Yeah, but 2 wrong answers kind of still painful though. It's not updated. Focus lab. You don't care about the rankings yet. Number of ones and the number of zeros. Can I do? So number of zeros, right? Okay. So because okay, let's say we have 100 zeros. That means that the string can be up to 10,000. So we just, and there's 4 to the 10,000, so I guess maybe 200, so yeah, 40,000. So that means that the number of zeros can be at most 200 in a string. Can we brute force that? I guess so. So then you do 1 by 2, so 200 by 4, it's going to be 8 million. Maybe that's fine, right? Yeah, okay. I think that's probably a good enough way of doing it. Okay, yeah. Fine. Let's give it a try. Maybe we'll have to convert it to Python or something, or Java or something. Okay. Yeah, okay. Okay, yeah. Fine. Oh, man. Oh, what do you write? Okay. if I am so frustrated right now for some reason. That's such a silly typo too. Okay, and now we have okay, so then L is equal to say can we handle 0 independently? I guess so. How do you handle 1? 1 is fine, and then 2 and it's okay, fine. Okay. L is equal to 0. That means that it's just order 1s, right? So then it's just group by. I don't know if this is the intended way, but it's better than nothing. Right, okay. 3 and 5. Alright, it's getting to a start. Yeah, I mean that's fine. Okay, and then now L is equal to 1. It's kind of weird. Then it's just so for every 0, it is just the count of left plus right, right? Okay, fine. Oops. Is it zeros or zeros with it? There's no yes or yes. I don't know. Huh, it's unclear. Okay, I don't know. Focus on the right things, Larry. Okay, okay, if I is equal to 1, then it's just, yeah, if I is 0, then it is just the one number of ones on the left. Okay, yeah, right, okay. Left is equal to 0, right is equal to 0, degree of freedom, okay, fine. Alright, so degree of freedom to the left, to the right. If I is greater than 0, then it's zeros I minus 1, zeros of I. Let's just go with Z. Too much typing. Okay, so then this is the number of ones. Minus 1, I think. So because if also this is not right for I is equal to 0 anyway, but it's degree of freedom now. So that means that if okay, yes, I think this is right for degree of freedom. Else then left is equal to Z sub I. So when the first, if the index is 0, then no degree of freedom. Okay, fine. If I is less than length of Z, and that's always going to be true. I meant yeah, okay. Then right is equal to I plus 1. Maybe. Right, so okay, so this is the then should have 1 degree of freedom. Okay, fine, right? Degree of freedom, right? Yeah, Larry, you silly goose. 8 and 17 seems a little bit high. Why? Okay, because for this 0, we have you have 2 degree of freedom, but we're double counting now, right? Huh. Yep. This. And it doesn't count if there are no ones at all. Oh yeah. Oh, I messed this up. Of course, for L is equal to, for zeros is equal to 1, then you have to have at least 2 1s. Silly Larry. Oh man, what are you doing? Yeah, okay. For some reason, I'm thinking of something else. What am I doing? Okay. You have to have 2 1s for 1 0. That's fine, right? So, okay, degree of freedom is, it's not degree of freedom anymore. It's just how far it extends. But which should be, the math is just so easy to be off by 1. Okay. So then, I did it for the wrong thing. Okay, so that means that the left is just going to be, yeah, okay. And then now the right is just going to be this, right? And then now it is the number of shifts, which means that it's going to be right minus left plus 1 maybe. Maybe this is off still anyway. I'm just going to run it real quick. So that's really wrong, but yeah. Yeah, okay, well. Don't click on submit by accident. Alright, 05, why? Tell me why. I need an AC. I think I'm running too hot. Okay, so this is 0. Okay, to the right is, oh, this is just wrong then. Oh, I took the wrong one. Yeah, so that's the last index. Otherwise, if this is the last index, then right is equal to, should be 0. It's the last inclusive index. Okay, fine. So I don't even need this. And this is equal to n minus 1, right? Okay. 8 and 13, still high, but that's okay. So 0, 0. Now you need, it's this. So this is the number, the length, right? Okay, so I don't know about plus 1, but this is the length of the string, right? Let's put it in here. So this should be 1. So the length is 1, but we want length. We want length 2. No. We want. Oh yeah. We want. But it could be more than that. That's the thing, right? How do you do the math there? Well, we want, okay, so we want how many strings there are of length 3, which is, I guess 1 plus is this amount. This is the total length. In this case, it's 0s, 1. This is wrong. Because this is 0, 1, 2, 3, 4. Is that true that I'm wrong? Because if the other way is 1, 1, 0, this is 0, 2, so. Oh wait, no. I wrote 3 anyway, so the math is right. Okay, so it's 3. But is that it? No, because that's just. Am I doing okay? All right. Wow. So it's length at least 3 that is bounded by this, right? How many length 3s? How many length 4s? How many length 5s? Right? Can we sum that up? So it's going to be this minus, so minus 3, minus 4. Okay, so it's this, plus this, dot, which should So okay, so then you have m is equal to this. So then now you have m minus 1, m minus 2, m minus 3 all the way to 0. So then that's going to be equal to m times, okay, so let's say we have 3, right? Then it's going to be just 0, so that's going to be, so length 3, we have one length 3, and so you have length 4, you have two length 3s, okay, then you have one length, okay, so that's right. And then now that is going to be 2 plus 1, so 2 plus 1 is, should be 2 times 3 divided by 2, no? Yeah, okay. Okay. Okay, I mean that seems right, but then for length 1, and then now we have to do length whatever, right? And I think I can do it with this math, right? Yeah, I think so. Maybe. Because we need at least that number of zeros, otherwise it won't count, right? Okay. Let's brute force 2 for now, and then I'll have to think about how to generalize it. Don't optimize the code yet. And the only, so maybe this will be off by, no, this no off by 1, because, okay, so it should be right for the inputs if my code is correct. So, okay. Okay, right, so for length is range 2, then now we have for I in range of length Z. Right, so if, well, but we want to start from 1 or L minus 1 to keep track, right? I mean, I could do some sand stuff, that's what I'm looking at, but I don't know. Okay, so then now if, and this could be minus L or something too, but something like that, but I don't know. This is very easy to be off by a lot. I have 40 minutes. I should be able to get this. I think this is right. Otherwise, okay, so then now if I minus if this is greater than or equal to 0, so length 2 should be this plus 1, right? Okay, yeah. In that case, then left is going to be equal to C, I minus plus 1 plus 1, right? Else left is equal to 0. This is way awkward, but okay, fine. I think this is plus 1 as well, so this actually ends up being this. I'm totally aware that this is so sketch. Wait. is that right? So this has to be length 3. This is not right. This has to be length. Oh, I guess I should do this as max 0. But okay, so because okay, so length 2 should be 6, so it is actually of. Okay, so I actually wrote this wrong. Oh no, I did the math wrong here. It doesn't have to be length 3 because you don't need 2 ones, you need 1 1. So that is actually wrong. What did I get? Oh, So this is actually 1. Yeah, okay, fine. Oh, whoops. Alright, well, that just makes it really awkward. So, for example, we have length 3. With this one, you have length 3. Right, so you have 2 choices, which is not true. Because on the right side, you cannot just have 1. Oh, you can, but we already counted that. So we're double counting. That's not right then. Like, I don't know how to do it quite right. Well, I mean, you could do it, but you could do it by capping left and right. Okay, fine. So left is equal to max left and I minus two. Okay. Still wrong, unfortunately. Okay, so we have 3 to start off. So at 0 index, this adds nothing. 1 index adds nothing to it. So this adds 3. Why? It is 3 because we have 2 and 4. So 2 and 4, we want 2. So this is actually no. I just suck at math. Okay, this is 4 and then 6. Okay, that is more reasonable. Maybe, don't know. Okay, so then now we want total length to be L plus L times L, right? So then now we have this minus total length minus 1. Yeah, and then left is equal to max left I minus total length minus 1. And then now, that math should be easier. Is this left-right thingies right? Why am I going this way? I think I only need to. No, this is. So if it's 1, we want to go that way, but you don't need to, right? We're just trying to count the number of things. This is a little bit off, but I'm going to just run it real quick. Yeah, it doesn't seem to do anything, which is good maybe. Oops. Doesn't even loop. I guess this loop is just weird. Okay, fine. But we want actually, we don't have to look above. We just have to press L, right? Yeah, okay, fine. Right? Yeah, okay, fine. just do something like this. All right, let's just run it real quick, see if we, nope, still doesn't seem to do anything weird, or it does. I minus L is equal to, how, what am I, okay, what am I want to do here? So this 0, oh, this is too restrictive. We don't care about this, we care about if I is greater than 0. Yeah, so then we just don't care. Yeah, the left side doesn't matter. We care about only the right side because of the symmetry reasons. Alright, 7, 7. Okay, I mean, that's a fascinating idea, but we can start playing with it. Okay, so left is equal to, that's not true. What we want is actually the same thing as before. We could do the asymmetry, otherwise we're just double counting. Also just being dumb. Okay. What's that do? Okay, yeah, I think this is more right. It's not actually right, but it's more right. Okay, why am I getting stuff here? 2, 0, and 7. Okay, length for 2 at 0. Okay, so then you have left, right, TL. I think I have to do some maps a little bit differently, but maybe not. I don't know. Alright. So LI, left, right. Okay, 0, 1. That makes sense for 2 zeros. Is that true? No, it goes up to here, but then it goes back. So you have no degree of freedom, really. TL is 6. Oh. No, I mean, this is right. What is the total before? Oh, I think maybe this is what I expect anyway. Alright, so TL is 6. Right, so we have length 6 stuff. M is going to be, this is 1. The longest that we can get here is 2, which is true because we have these 2. And then minus, oh, so M is negative. I guess I just didn't have this part up. Yeah, okay, fine. And then the M square adds a mix of weird. Okay. Alright, that's kind of better. I don't think, well, the first one doesn't, first one we should be right without the L is equal to 2, so that means that this part is wrong. So we have to kind of debug this actually a little bit. Okay, so you have 3, and then for 1 zeros you have 4. Now you have at least 3. Okay, so you have length of at least 2, but we have the max length is 3, right? So this is going to be 2. Left, right. Okay, I did mess this up because this should, no, because you can have in, okay, I see, because you could keep extending as long as it's not bigger than the last number. Okay, so, or next number, next 0. So you don't want to go to the next 0. Okay. Okay, you cannot go, how am I doing anyway? Okay, at least that's less embarrassing. But okay, how do I do the next? So this is the previous 0, which should already be here. Do I need this? Is this confusing? Why is it me get, oh, because of this maybe, but no, this gives me 3. It's because because it takes these 2, but we need the left to be 0. So okay. So I mean, everything it is possible. It is just that it. Because we want something that's at least length 2, but contains the current 0. But if we have 0, 1, 1, 1, you can't extend it. So my math is just really bad at counting this, honestly. Is there another way of doing it? Am I doing it funkily? In a funky way? I think I'm doing it too fancy. Maybe. Can I brute force in a smarter way? No, it's degree of freedom. So on the right side, okay, I see. I'm confusing my degree of freedoms and stuff. Okay, so then now we have this, right? So then now, degree of freedom on the left is going to be z sub I minus left. And on the right side is right minus z sub I. And then now, we have 200. Well, that's the number of ones, not the number of degree of freedom. Because then now you have to combine them in a weird way. Huh. Because then now you have to combine them in a weird way. Because it could be like 1 from each, which is not the same. And then you could have multiple. That's why it's so tricky, huh? So it's not just degree of freedom. Maybe there's a formula that encapsulates this. Maybe I just don't know how to do this one. I'm just going to keep tanking. The 2 long answers are tough, but okay. How? I'm going to try. I think the way that I'm doing it is just very funky. I mean, I think the idea is kind of right, but I don't know how to count it. So I have to do it another way. I have about 25 minutes. I mean, the way that I still kind of want to do it this way, but it's just, I don't know how. I don't know how to not double count. Oh, maybe this is the hint. Maybe this is the hint, kind of. I don't know. Can we do it inverse? So 1, 0. 1 0. Oh, maybe that is the okay. Reset. So we have 2 zeros. The number of non-special is going to be either 0 ones, okay, 1 1, or 2 ones. After that, it's just whatever, right? So then now we have 2 of them in the middle. Then now you just count the number of so you count 1 ones, 2 ones, but then you have to still extend to calculate the ones that extend a little bit more, right? Like 0 0 1 is not good, but we have to figure out how to subtract that. I don't know how to do this one. Man, and people are starting to get it. I mean, which, you know, given an hour, I guess it makes sense. But if only I didn't have 2 silly mistakes on the other one. Okay, rethink. Okay, we have 1 0. Okay, you have 2 zeros. You can have up to 1 1 in between. Okay, so we have 1 0, you have 0, we have 2, then it goes up to 3. It doesn't have to, but it doesn't have to be in between, right? That's the thing. So then you have 0 0 1 1. That's no good. We have to take it out somehow. How? The number of zeros is going to be the key, but I just man, today I'm just struggling. Luckily I did the other one first, but some days you don't know. I'd like to give it to you though. 40,000. Am I missing like a binary search or something? I don't think so, because it depends on the number of zeros, but maybe I don't know. Okay, but I'm doing prefix sum. How would that even work? I don't know. That's my only other idea, really. Prefix sum. Square? I don't know how to do the square, honestly. Is there an idea that I'm missing? Like 1, 0. I don't know how to do this square thing. I don't know how to deal with it. And apparently a lot of people don't, so I don't know. I'm gonna drop some rating again, but like the problem is the inverse is just doing if I'm doing the same way, it's just exactly the same. Can I do the degree of freedom in a better way? Not really. "21 strings." Yeah, because okay, yeah, this is fine. You can't just add everything. Not everything is valid. And then everything else is just kind of the same thing that I've been doing. Just minus the length, but it could go more. Am I doing the math stupidly? So the degree freedom is 1 on this. Maybe I'm just doing the math wrong. Okay, so the degree of freedom is left side and right, but left plus right has to be greater than some other amount, right? So it is the number of counts in which left plus right. Okay, so this is the degree of freedom. Okay, so it has to be maybe I just need to work it out. Maybe I'm being dumb. Let's say we wanted to length has to be at most or at least 2, right? So that means that it is going to be left times right minus so that's the degree of freedom minus where left plus right is less than, which is how many cases are this? It's like a n choose 2. Like a minus I, right, minus L minus I, and then times the summation from my right. That means that is going to be 5 plus 4. And also, that's not degree of freedom anymore, right? That's just, no, that is still degree of freedom. Just very awkward. I don't know. I have 12 minutes. How come so many people got this, but I don't know how to get it. I don't know why. I guess I'm just not having my day. I mean, I guess it's not in ChatGPT. At least that's good. I don't know how to do it. For I. I don't know. I mean, I guess I could do the 0 events, but maybe it's just a variation of this, I guess. I don't know anymore. Maybe I could do brute force on L in a better way. Yeah, okay, let's give it a spin. I have 10 minutes. I don't know if I'm going to finish this. Right. I guess this is fine. But this is the next 0, even if it's 0, right? And then now we want to go. Okay, so that's 1 0, right? So total we add by next minus I, because that's just the number of ones we have. And then, yeah. I don't know, whatever. If nope, this is Z. Okay. Okay, so with this, right? So if this is the next 0, so then now we have ones is equal to I guess we don't need to do this yet. So ones is equal to, or zeros is equal to j plus 1, and then ones is equal to this thing minus I minus zeros, right? So then now we just have to count how many extras are there. So yeah, so then we have okay, I think here we need to something like that. 7 minutes, maybe this is right, but I think this is actually a good idea, but I think I'm doing a little bit slow. If I had more time, maybe this would have been okay. This should have been, so this is just the number of zeros plus, so that's the length. So that's the total length. That we need, and then the length is equal to minus I, so then it is just the length minus this, something like this. I have 6 minutes, maybe I could get this to work. On intent, ZA. Okay. So that means that is to the n. If Z, then total which is n minus I, right? 3 and 5, that's okay, maybe. I mean, this seems like I'm missing an off by 1 somewhere anyway. But this is this plus 1 is the length. Number of ones, number of zeros is just j plus 1. Okay. Is it though, Larry? Next is this plus j, so 0. So if this is 0, do we have 1? 1, we count. Mm, 619 is kind of good. Maybe I'm now off by 1 somewhere. Okay. 619. Okay, well, let's see. Okay, you have 0. 0, you have 1. That's not true. I mean, that is really wrong, but okay. So what I want is that this 0 Okay, so there's 1, 0. This 0 being one thing is weird. Okay, so that means that is in this part, so that's okay. So that means that ones. 0, 0, 1. Length is not 1. Length should be 1, but zeros. If this is a 0, then this has a 0, I guess. Yeah. What is this? Yeah, this is length minus zeros. Right. Oh man, why do I have typos now? I have 1 minute. I'm not gonna get it. But 0 is 1. The 1 is length. Oh, but yeah. I think if num sub or s sub I is equal to 0, I don't know if this is correct, but 315. 315 is closer. I might go overtime on this anyway, but yeah. 1, 2. Okay, now I'm putting too much. Okay, so 1, 2, 3, 4, 4 or 3 should have 2. Is that right? Well, now this 0 should have more than this, right? So you have 1, 0. But we have to go to the end. That's why. I'm so close, but I mean, I guess I'll just have to stay overtime, but I've got this idea too late. Okay, because then I'm off by ones. Because this 0, and even this one, no, I think this is fine. This 0 is the... Because basically, if, okay. Then you just have the same thing, but this is now n. Okay, well, that's wrong. Length is n minus I plus 1. Is that right? Let's give it a spin. I mean, time's up, so I'm done. But I want to see it. So 4. Well, oh, 0 shouldn't be j. 0 should be j minus 1. Okay, well, that's even worse somehow. Okay, so 3, 3, 6. Is that true? No, this should be n. Oh, okay. Okay, so this is right, but then why is it? Is this right? The degree of freedom? That's the number of ones. So this isn't right, but yeah, maybe this isn't right. Also, 0 should never be -1, I think. Oh, I guess so. I think this this only need to happen if it's. I think we want to have this idea of going all the way to the end. So this is actually just J. Right? Yeah. So you have 4 0. Now that's not even right. Because you have this. And then you have 0. Oh, because of this thing. Maybe you don't need here. Okay, but still overcounting. We have 3 zeros, 2 0, 2 2 4, 1 2 3. That's right at least. But then I think this formula is not right. Okay, 0 0 2. You have 1. No, this should be 2. So this is definitely wrong. Yeah. Wait. Two, you have 1. Why? Because you have test 1 2 3. Yeah. I think this is just very awkward, honestly, but it should be 3. You have 1 0, so this is any of. Now this is really wrong because then it's just saying length 2, which this is awkward anyway. This is 2 for zeros, so that's why it's overcounting. Maybe. Well, I mean, there may be other ways it's overcounting. Trying to see where this is wrong, to be honest. Still, 1 2 should the length is 3. Okay. So zeros, this is 1 plus is 2. So 3 minus 2 is 1. I guess that makes sense. I think this is just off by 1, but I don't think that's because then now we're even more overcounting. Right? How do I get 7? So this is undercounted because this should be 2. And then 3 5 is definitely way wrong. Does this only work? And this is undercounted, yeah. Is this undercounted in a good way? 3 is 2, that seems right. 4 is 3, that seems also right. So it's just missing 2 from here. So maybe this has to be n s of I is equal to 0. I don't know. Now I'm like just trying YOLO things, right? And yeah, this is still wrong though. 2 1 plus 1, but I mean I don't think this is right. I think the counting is right, but I think this is just like fitting the test cases. So I'm gonna just YOLO submit, but I have no confidence that this is right. It doesn't make sense to me, honestly. But it might also time out, I guess. But no, it should be okay. N log n. I don't know why this judging is so long though. So I mean, why not just tell me a wrong answer real quick? Okay. I mean, this should not have taken like 10 seconds, for example. But yeah, I mean, I don't think this is right, but I don't know. Honestly, I have no idea. Mm. Yeah, I was trying to do, and then on the last one, does that kind of make sense? I think this is the right idea though. Why is this wrong? I mean, it's wrong for this case, which, I mean, I think this case is a little bit awkward for sure. What's 110? So 110 means that 1, 2. Why do I have 3? 0. So I have 3 because, why do I have 3? Is it because of, no, I mean, so this doesn't even execute, so just this, this is kind of awkward, but okay. So the next is this thing, right? So total, this is the thing. I think this double counts maybe, I don't know. Like this is way awkward. Because this is the 0 length. This is 1, 1, right? So 1 is going to be da, 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 da. And then, let's put this back again. Why am I wrong here? 0, 3. Nope. 1, 0, 1 is the one. 1, 0, 1, length 1. That's not right. This is, I think I'm just not consistent in how to find it because I just got very confused. Because this should be j plus 1. Yeah, this should be j plus 1. I don't know why this is this way. Unless this is the case. Which is why it's a little bit confusing. Okay, wait, rethink. I think this is just this, right? Maybe? Why is this wrong? Okay, well. We have 101, which is definitely not, I mean, that's one of the possible answers. So that's for, this is equal to 0. Maybe we need to take this out. This just looks really awkward right now. Basically, this is saying the next 0 is but this is only if this is an I or a 1, that's why. But does that fix it? Nope. 101, why? So this is j is 0, okay, fine. 101, okay. So this is going to be just plus 1, that's fine. Oh no, this is the 0 case, whoops. This is 022, which is definitely not right. Right? 022, which is, yeah, not right. Because basically we're at this index, which means that we have at least plus 1. It is just that, yeah, okay, I think that's fine. Okay, let's debug this real quick. 1, 1, 1, 2. So it sums to 1. That's fine in theory. I think I need, this is this, you want the index that is this minus 1, so this is the right side, right? I don't know, let's just get rid of this. This is so confusing. Let's just leave it here, fine. Okay, right. Then there's this. This is the total length that we care about of all the ones. And then, yeah. Right, didn't I have some? Oh, and then it just doesn't loop. So this is J, then this is 1, then this is the next one after that, right? Okay. Then I guess I can just do. I think that makes it a little bit better. Then now we see 1, 0, 1. Sums to 1. That doesn't make sense. Okay, that makes sense, but okay, let's just get rid of this. And binary search we don't even need per se, but okay. Because then now you have, so this is 0, so next, now what we want is this, but we want this. So this isn't the, oh, that's why I confused myself. So this is the right side, the length is equal to the right side minus I plus 1. The number of zeros is just going to be, okay, right? And that should be good for ones, I think. Yeah. That's the degree of freedom. Okay, fine. I don't know why I'm so bad at this today, but well. So we have this, you have 1, 0, 1. That makes no sense. Alright, let's just keep it simple. I'm confusing all my outputs. Okay, 1, 0, 1, so I guess I was right. I just take this out for now. I don't think it did anything, but okay, 1, 0, 1. One, 0, 1. That should never happen for, okay, well let's look at I. And I is 0, J is 0. Oh, this is wrong again because now I changed the definition. Okay, so then now 0 has 1, which is wrong, because then now we have the second 0, which we have this, which gives us 1, 0, 0, 1, 1, 2, right? So this is 2 minus number of zeros, which is 1. So is this plus 1 maybe? That's really wrong, but okay, fine. This is only if this is I though, so I don't know if this is a 1. Because if this is 0, then it's a little bit awkward. Because if this is 0, then the right side is going to be, is this right at least? No, it's 3, 1, 2, so this is wrong already still. It should not be 3. Length 2. Just can't get anything right today. Length 1 should not be 2. Well, I mean, okay, there is 2 things because it, no. Length, so it's, okay, so the total length is 1. We want the total length to be at least this. Which is 0. So 0, so total length is 1 minus required length is 0, so then you have 2 degree of freedom because it's 0 and 1, but then you don't want 0 elements, that's why. So Huh. I think we need to do this so that we don't do length 0 elements, I think. Okay, I mean, overcounting is actually pretty bad. Undercounting would have been a little bit nicer, but that's not great. So let's at least check this one. So 0 0, nope. 1 0 2 2. That's actually good. 1 2. 3 4 is 3 and 2, so 1 2. Okay, so actually pretty good for this one. 17 not so good. Maybe for the length 2 things. But okay, so you have this case. Man, I am struggling. Sorry, just commenting on the things. Don't just off by once, maybe. Okay, so 17 is definitely not right because they tell you the answer. So how do I get 16, right? So okay, so you have this solution, this thing, right? So if I expect output is going to be 1 is equal to 1. The second 0, oh, actually that's not true. It's going to be 2. Yeah, sorry, I'm getting distracted. I mean, a little bit post contest, I'm not as time rush, but okay. So that means that okay. Let's actually just check. So it thinks it has 5. Why? 1, 2, 3. Is this right? No, 4. Is that right? Let's just write them out. So you have 1. And I am struggle town these days. You have 2, that's right. 3, 4, 5. Okay, so that's good. That's a good example. The second one has 2. I don't know if I handled the zeros correctly, honestly. So we'll see. So second one is 2, so that's gonna be 1, 2, and then that's it, I guess. I think because this is not good, and there's no way that's good. Okay, and then 3 is gonna be just 1, 2, 3, 4, and then the next one's gonna be 1, 2, 3, and then the next one, this maybe 0, 1, and then 1, right? So that's 5 plus 6, 11, plus 5 is 21. No, 16. Okay. But I have 5. So 5, 2, 4, 3, 1, 1. So we have 5, 2, 4. Yeah, the zeros are wrong. Oh, no, that's not a 0. That's a 1. Okay, so it thinks 2. So this thinks that it is 2, so 1, 2, that's right, up to the first 0, and then the now you have 1, 0, you have 3 1s, and 1 0, which is true, and length 4. Okay, so you have, yeah, just 2, right? Like, how did you get 3 here in this one? It's 3 here because L is, maybe my math is just wrong. L is 4 minus 1 plus 1, so that's 2 plus 1, so that's going to give me 3. But that's not true, right? Why am I wrong here? With this 1 0, we have, I have to do another max, I think, on the number of the degree of freedom, because I'm double counting, I think, one of these as a result of it saying that, okay, because so this is the force length, which is 1, and because the length is 4, oh no, the force length is 2, because, and there are, it's length 4, it thinks there are 3 ways to do length 2, which is true, but it double count these 2, so I have to do another math on, I guess, where the last zeros are. Yeah, okay, that makes sense. Oops. So extra is equal to okay, so it's equal to right minus how do I do this cleanly? Because there's so many like edge cases. Okay. So basically here we only have 2 degrees of freedom at most. And we have to expect that. Right? So okay, so then now that means that the degree extra, the actual degree of freedom, max freedom, is just equal to the right, or this thing actually, where the 0 is, and no, and the previous 0, or I. If j is greater than 0, then this is the case. Yeah, the degree of freedom is going to be +1, and then it's this, whatever. I mean, I there's some optimization here, but whatever. Does this 1 still apply? I don't know, actually. Did I mess something up? Oh, wait, no. Well, this is subtracting. We're doing something, but subtracting the degree of freedom. Oh, no, no, no. So it should be min of here, because that's the most degree of freedom that we have. Okay, not on the subtraction, because I just wasn't paying attention. Is this right? Still no idea, honestly. Let me just get rid of some other. Where's my other print statement? Oh, this one. You know, YOLO. No confidence at all. And somehow it's going to still take a while to judge. Why is this time? I mean, if it times out, maybe that's fine. I don't know what to say about this, but okay, time limit exceeded is fine. Huh, didn't expect this, to be honest. Oh, well, I mean, it's just, okay. I mean, I guess I'm not super surprised because of the 200 thing. But, and actually even faster, but like, because I feel like this is way trivial to do on ChatGPT to Java. So that's why I kind of thought of it that way, but let's see. Convert to, I mean, it's good though, Java please. I mean, if you do the math, it becomes 8 million, right? And 8 million is kind of like Sketch in Python. But so I kind of, it was like back of mind. I'm like, that was one that I did not worry that much about, per se, if that makes sense. This should be a long, no. Oh, and this doesn't do anything, I think. So we could get rid of it. Oh, I wonder if that makes it fast enough if we just get rid of silly things. I just forgot about that I still have this. I mean, that doesn't do anything. Technically, I don't even need binary search on this, so maybe we could speed that up. So, but it's just n times that, so I don't think that matters. Okay, let's give it a quick submit, just real quick. I mean, it's fine with TLEs, but we can also just do a sliding window thing on that part. And this else thing is just me being lazy. You could probably terminate this a little bit quicker, actually. No, I mean, this actually should terminate pretty quickly. If, for example, if I plus, okay, let's say, I guess zeros is just, so j plus j times j, so that's the length, is greater than or equal to n, then we also break. Maybe I'm off by 1, but I think that's roughly right. Yeah, it's only a little bit faster. I mean, ooh, but and also wrong apparently, as you can see here. Somehow I got this one right though. But I plus do. I don't know. I mean, I don't know why that is wrong actually. Honestly, maybe I'm just off by 1. Like maybe if I do plus 1, it's fine. Alright, let's just give it YOLO submit, just for timing's sake. I mean, I know that this is not a big deal anyway. Convert to Java please, using all longs. Yeah, with times out, it's fine. I mean, yeah, we're after the contest, right? But that's funky. They don't have binary search in Java. Am I reading this right? How did I do it before? I just kind of copy and paste, but why does this one have? Yeah. Huh, that's weird. I could just also run this real quick. 7? What? Is this not a? Oh, it is an int. Huh. Actually, I'm wrong. I thought you needed this for it, but I was wrong. Huh, why is this wall? Okay. 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 Because this brick is here for some reason. I don't know why. Okay. Right, is this fast enough? I don't know. I mean, yeah. Yeah, half an hour after the contest, but I'm still happy about it. I think let me do a quick see if I can optimize this real quick, because basically the only thing that I can optimize is the binary search, or at least the obvious thing. Yeah. Actually, I guess I can just run it with. Oh, this doesn't mean anything. Yeah. Okay, so maybe next is equal to 0, just to kind of just want to see the running time performance. Okay, so that doesn't, the binary search, as you can see, does nothing, or maybe a little bit, but not fast enough to get rid of it. That's wild. I wonder what the solution is, but this is the way that I would have tried to do it during the contest, and even getting it right would have been okay. Yeah, I don't know. Huh. I mean, this is, and I mean, I guess the way that I tried to do it during the contest was that I was trying to combine these, but yeah, but I think this makes it a little bit better. I guess this math I could kind of combined, because then well, this one, let's take out the optimization real quick, which I think is fine, but then now how would I optimize this real quick, right? Well, for I, we know that we have this thing, so that means that it's going to be that is just so max freedom doesn't change. The only thing that changes is I plus 1, right? So then now in theory we just sum all this, or we sum all this to this, right? It's just but and I guess you can write a formula for that to make it like. Thanks for watching, everybody. Hit the like button, hit the subscribe button, join me in Discord. Let me know what you think about this contest. Yeah, and this part. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.